So we know how to measure, we know how to write in scientific notation. Now the only thing that we need to do with our numbers is sometimes it requires us to do some conversions into units that we need to use for an equation or to get it to be a slightly more manageable number. And so this is basic metric conversions. This is why the metric system is so great, is it's based off of powers of 10. And so let me go over the scale real quickly. You probably are familiar with, let's start with the big, you've probably heard King Henry died upstairs drinking chocolate milk. Now I'm writing it backwards because I want my big units on this side. So this is big units. And these are small units, okay? So K stands for kilo. H stands for hecto. Deca, this is the base unit. Then we've got deci, centi, and milli. Okay? Now, there are some other really big, really important measurements as well, the ones that you're familiar with. I'm going to leave some blank spaces here because these units are not really important, but there would be some prefix that would go there. But this would be what's called a capital M, which is mega. And then if I go 3 more, that'd be G for giga, which you've probably heard for computer purposes. And then another 3, if you wanted to, would be T for tera, like so. Okay. I can also do the same thing with the smaller units. I can go 3, and then this would be what's called a micro. Micro, and they use the Greek mu symbol for that. Then 3 more would be, I messed this up. Not 3 more, it just 2 spaces in between those. This spot right here would be N for nano, like nanotechnology. And then if you got even smaller than that, that'd be pico, okay? And so this is basically the scale that we have here. Now, the question that I often get from my students is, what is that base unit? Well, the base unit can be a lot of different things. It's dependent upon whatever you're measuring. So like, for instance, mass is measured in, the base unit is grams in the metric system. If you're measuring like time, that would be seconds. If you're measuring volume, that would be liters, capital L. If you're measuring energy, that would be joules. And typically speaking, this is generally speaking what we mostly use in chemistry. However, there is one more unit that we need to talk about, and that is length. And that base unit is a meter. Okay. So now let's talk about how to use this scale. And basically, before we jump into some examples, the scale is brilliant because this unit right here, the deca unit, is 10 times bigger than the base unit. And this hecto is 10 times bigger than the deca, but 100 times bigger than the base. And kilo is 10 times bigger than the hecto. It's 100 times bigger than the deca, and 1,000 times bigger than the base unit. And so it's all based on adding or taking away a 0. So now let's talk about some basic examples. I like to teach my kids to move decimal. That's totally fine. I'll show you one example at the end where maybe it's not so convenient to move the decimal. So we'll start with the green example here. I've got my very simple scale up here. Remember, these are big values over here, and these are small values over here. Okay, and so when you convert from within simple calculations in the metric system, I want to focus on where the prefix is. And so in this case, the prefix is K, which is right there. Okay. Now I want to identify where the prefix is at the end. But notice how there's only one letter on where I'm trying to go to. And that means there is no prefix, which means that is my base unit right there. So it's right there. Okay. Then what I need to do is I need to come through and identify how many spots away is it. So it's 1, 2, 3. So I'm going to get rid of that so I can save it. So, but it's 3 spots away. So 3 spots. And then I need to ask, is the unit getting smaller or bigger? Since the unit is going from kilo to, it's going like this, kilo 2 meters, the unit is getting smaller, which means the number has to get bigger. So therefore, I'm going to take my 2.3 as written, and I'm going to make it get bigger by 3 decimal points. So 1, 2, 3. That's equal to, and then you just fill in zeros here. So then it's 2300, and that would be meters, and that would be the correct thing. Now, I did tell you that this value, because it's based on 10, is 1,000 times bigger than the base unit. All you'd have to do in this case is say, does the number need to get bigger or smaller? Bigger. So therefore, I could take 2.3 times 1,000 because the kilo is 1,000 times bigger, and that should give you the exact same answer. Now, let's talk about the red example. The red example here, let me erase this scale here. Okay. The red, if I am identifying where I'm at, the red starts with a base, the prefix M, and then goes to capital D, deca, right there. And so I can tell that it is 4 spots away. So it's 4 spots. And in this case, the unit is getting bigger because it's going that way. So therefore, I have to get the number smaller. So therefore, I'm going to rewrite my number. And now I need to make it smaller by 4 decimals. 1, 2, 3, 4. And so therefore, it would be, add in zeros here, 0.0000, that's a lot of zeros, 0032 deciliters. This would not be something typically we would write the unit in. But maybe it's important for an equation or something like that. Again, you could think, okay, this unit right here, the deca, is not 10 times, not 100 times, not 1,000 times, but 10,000 times bigger than the milliliter. Now, so therefore, you could say, okay, 10,000 is the difference between them, the factor between them. So then would I take 0.0032 and divide it or multiply it? Well, if the unit is getting bigger, the number needs to get smaller. So therefore, I would divide those guys and still get the exact same answer. One more problem here. This case right here, I don't even have it on my scale up here. But I know by looking back at this right here that the nano is all the way down here. And I think I had base unit. Yeah, base unit of 4 here. Okay. So then, yeah, you can move decimal in this case, but in this case, I think it'd be beneficial to just simply ask how many times bigger is it, okay? And so you see 1, 2, 3, 4, 5, 6, 7, 8, 9 spots away, okay? That 9 spots away could be summarized by doing this. Instead of going 1, 0, 0, 0, 0, 9s, you could go 10 to the 9. So that's 10 to the 9th power, which would be 9 more zeros added to it. 8 more zeros, excuse me. And so the question now is, are you going to take 4.0 and multiply it or divide it? Well, if my unit gets bigger, my number needs to get smaller. If my unit gets smaller, then my number needs to get bigger. So in this case, the unit is getting a lot smaller, which means my number needs to get bigger. So in this case, I would multiply it. And what do you know? We have the answer already written in scientific notation for us. So therefore, that is our final answer in nanometers like that.